Hello everyone, welcome back to permutation class. Let's get started with the class now. Right, find the number of ways to arrange the letters from the word tuah, T-U-A-H, where the letters are not repeated. Fill in the blank first. For the first box, we have 4 choices. We can use T or U or A or H, right? Let's say we choose U. So U is fill in the first box. So left over, we have T, we have A, we have H. So we have 3 choices or 3 ways because the letters are not repeated. So that means we cannot use back the letters that we used just now. Alright, it is given that the letters are not repeated after filling in the first box. Therefore, we have only 3 ways or 3 choices to choose the letter to fill in the second box. So, same thing apply to the third box. We have only 2 choices. We have 2 ways to choose the letters to arrange the letters into the third box because it is given that letters are not repeated. So after filling in the second box, we only left 2 choices. So there are 2 letters for us to choose. So there are 2 ways. So we will actually fill in the third box with either one, and hence we left over the only letters. So that means we only have 1 way to arrange the last letters. It is because the letters are not repeated and we cannot use back the letters that we fill in the first 3 boxes. So hence there is only 1 letters for us to end with. So in short, this is actually permutation. So we have how many ways altogether? So the total number of ways is equal to 4 multiplied by 3 multiplied by 2 and multiplied by 1 because we have to follow the multiplication rule. Alright, so the answer is 24 ways, or is okay, we can write 4 factorial, but 4 factorial is 4 times 3 times 2 times 1, so which is 24. So that means there are 24 ways for you to arrange TUAH. Either you start with TUAH or TUHA, or you can start with any other letters like HUAT, okay, HUTA. So the number of ways to arrange these letters is called a permutation. So for permutation, the order of the arranging the n objects is very important. So number of permutation of n objects is given by the formula n factorial, or you can say as npn. So if you press your calculator, you can press 4p4, which will give you 24, or else you can key in as 4 factorial, which is equivalent to the 4 times 4 minus 1 times 4 minus 2 times so on and so forth times 3 times 2 times 1. So the answer will be equivalent to 24 ways. So today I introduce to you the formula of permutation, which is n factorial, or you can say as npn, or you can say as n times n minus 1 times n minus 2 times n minus 3, so on and so forth until 3 times 2 times 1. So do you know that 0 factorial is equal to 1 and 1 factorial is equal to 1? Because 1 factorial is 1, 2 factorial is 2 times 1. 3 factorial is 3 times 3 minus 1, which is 2, times 3 minus 2, which is 1. Okay, so you notice that all the number are end with 3 times 2 times 1. 5 factorial, 5 times 4 times 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is equal to 7 times 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial is equivalent to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, so on and so forth until never ending. So you can keep on writing the factorial in this pattern. You notice that the number is very systematic. You can see the pattern number 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13 until 14. So this is the systematic order of the permutation. You can see the order is very organized, right? So now I would like to discuss the concept of the 0 factorial. But before we know about 0 factorial, you must know the factorial means you have to use a formula, and factorial means n times n minus 1 times n minus 2 times 3 times 2 times 1. And why 0 factorial is equal to 1? Let's study why. If 3 factorial is equal to 3 times 2 times 1, and then we can write as 3 factorial is equal to 4 factorial divided by 4, isn't it? So if you write 4 factorial divided by 4, you will get answer which is 3 factorial. So in short, we can expand this to 2 factorial will be 3 factorial over 3, right? 3 factorial is 3 times 2 times 1. You divide by 2 times 1, you get, okay, 3 times 2 times 1 divided by 3. So you will get 2 times 1, which is 2, right? Then how about 1 factorial? 1 factorial, okay, it should be, if you see the pattern number, you should know that 1 factorial will be 2 factorial over 2, right? So 1 factorial will be 2 times 1 over 2, which is equal to 1. 1 factorial is 1. Now, very interesting, how about 0 factorial? 0 factorial is equivalent to what? Is it equivalent to 0? Now, let's follow the pattern number. If 1 factorial is 2 factorial over 2, then follow the pattern number. 1 factorial should be equal to 1 factorial over 1, right? So we will actually simplify 1 factorial is 1 divided by 1. So we are still getting 1. So 0 factorial is equivalent to 1. What it means by 0 factorial? It means that we choose not to arrange. Choosing not to arrange is one way. You choosing not to do homework is one of the way, right? So remember that 0 factorial is equal to 1 and not 0. Alright? Okay, now I would like to discuss how to simplify 11 factorial over 9 factorial. In order to simplify 11 factorial over 9 factorial, we can use a formula, or we can just expand 11 times 10 times 9 times 8 until 3 times 2 times 1. And you can also expand the 9 factorial. Okay, so you can draw a line which is very long, and then you write 11 factorial as 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3 times 2 times 1 until 3 to 1. And then you can also write 9 factorial as 9 times 8 times 7 times 4 times 7 times 6 times 5, and then end with 3 times 2 times 1, right? So then you can simplify the 9 factorial. So the answer is just 110. Or maybe we can just write 11 times 10, and then we will just 9 factorial multiply by 9 factorial, and then you divide by 9 factorial, and you can cancel the up and down with the 9 factorial. So you will get the answer, which is 110. Alright, so that is much more simplified, and then you can get the answer very fast. So this is so-called shortcut. Alright, so in future you can just do like this before you press your calculator. Alright, so then you can do in a faster way. For B, 6 factorial, you can write as 6 times 5 times 4 factorial over 4 factorial. You can cancel out the 4 factorial, and then 2 factorial is 2 times 1. Or you can just expand 6 factorial as 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 over 2 times 1. But then it actually take very long space. Okay, let me show you. You will write 6, and then you will times the 5 times the 4 and 3 and 2 and 1, and the 4 factorial is 4 times 3 times 2 times 1, and then 2 factorial is 2 times 1. Alright, then we can just simplify to the simplest form. Okay, so if we simplify, our final answer will be just, okay, let's cancel out up and down. Similar one is 4 times 3 times 2 times 1. Okay, so we'll get 2 and 6. You can cancel, you can simplify, become 3 times 5, right? So the answer is just 15. Or you can write as 6 times 5 times with the 4 factorial, so that you can cancel out with the denominator 4 factorial. And your answer is actually just equivalent to the answer just now, which is 15 also, right? So the answer is 1, 5. Okay, so we are not using calculator to find each of the following value. So then next we are going to solve the next question. So it's up to you. You want to make it longer and then cancel the repeating one up and down, or you can use a shortcut. Find the number of ways to arrange all the letters from the word bija when repetition of letters is not allowed. So we are going to arrange all the letters B, I, J, A, K. They are actually different. So that means we are going to arrange 5 objects out of the 5 objects given. So you can write as 5p5, or you can just use the n factorial, which is 5 factorial. So the answer will be 5 times 4 times 3 times 2 times 1, right? Okay, so you can also press your calculator as 5p5, right? So if you use a formula n factorial, it will be n times n minus 1 times n minus 2, right? So on and so forth, 3 times 2 times 1. So if you write, will be 5 times 4 times 3 times 2 times 1. So the answer is 120 ways. Okay, so we have complete this one. This is quite simple, arranging the 5 out of the 5. The word API is arranged in a line. If we want to arrange API in a line, it's arranging 3 objects. So we have 3 times 2 times 1, which is 3 times 2 times 1, which is 6 way. Or you can say 3p3. So that means we can start with the API, IAP, PIA, AIP, PAI, IPA. So we have 6 different arrangements. So we call it 6 ways. What if we are going to arrange in a circle? Arranging in a circle is different with the arranging in a line. So let's see. If we are going to start with the API, okay, let's say we are going to observe why API and IAP and PIA, they are the same. Now let's say you are A, okay, at your left is P, your friend, at your right is I. Now if you change a position to another place, at the left of your side, left hand side is still P and the right still I. You change another position. So if I just change a position, it looks like the I is to my right and then the P is to my left. So now if I swap the position of I and P, that means I and P change a place. So if I and P change a place, so to my left is I and to my right is P. So if I swap the place, okay, let me see, to my right is still P and to my left is still I. If I change a position again, to my right is still P and to my left is still I. So it means to me, even though I and P change a position, this another arrangement, okay, but to me the 3 ways AIP and PAI and IPA, it still looks as the same to me. So in short, for a circle, for API, arrangement in a circle is just 3 minus 1 factorial, which is 2 factorial. So if let's say we have n object arrangement in the circle, so the formula is n factorial over n. But we have learned n factorial is equal to n times n minus 1 factorial. So we can cancel out the n, so it becomes n minus 1 factorial. So please remember, when arrangement in a circle, the number of ways will be n minus 1 factorial. Okay, so let's see this question. Determine the number of ways to arrange 6 pupils to sit at a round table. At a round table, the number of ways to arrange 6 pupils is 6 minus 1 factorial. So we will have 5 factorial, right? So the formula is n minus 1 factorial. So remember that for a circle, number of ways to arrange is always n minus 1 factorial. So we will take 6 minus 1 factorial. So the answer is just 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. So we get 120 ways. So for a circle, the number of arrangement is different with the number of arrangement in a linear way or the linear form. Alright, so let's proceed to the next question. Find the number of ways to assemble 12 bits of different colors to form a toy necklace. So we have 12 bits. So n is 12, right? So the 12 bits are of different color. So we need to arrange the bits in a circle. So number of ways to arrange the bits in a circle. It is found that the clockwise and anti-clockwise arrangement look the same. So we need to consider that clockwise and anti-clockwise, it will give us the same arrangement. So hence, if we flip, okay, we will notice that they actually looks the same, right? So in this case, we need to divide by 2. So for a circle, it's a bit different. We have to consider the clockwise and anti-clockwise. If the anti-clockwise and clockwise arrangement looks the same, then we need to divide by 2. So the number of ways to arrange 12 bits in a circle is actually need to be divided by 2 due to the clockwise and anti-clockwise arrangement looks the same. So let's work it out. The answer for arrangement in a circle, number of ways of arrangement, 12 objects in a circle, it should be 12 minus 1 factorial, right? So we will take 12 and then we need to minus 1. And we need to put factorial before we divide by 2. So then the answer should be 11 factorial divided by 2. So we can just press a calculator to get the answer, which is very big number, 199,58400. Okay, so this is the number of ways to arrange 12 bits to form a circle necklace. So please be careful when you do the arrangement in the circle, and always remember you have to minus 1, and if the clockwise and anti-clockwise look the same, then you have to